Hello, please briefly introduce yourself. Ask for brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic Terraforming Mars.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma, Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Now, let's dive into the topic of terraforming Mars. This is an intriguing concept that has captured the imagination of many science fiction enthusiasts and real-world scientists. What is terraforming? Terraforming, in a general sense, refers to the process of modifying a planet or moon to make it more similar to Earth and suitable for human life. This often involves changing the atmosphere, temperature, and ecological balance of the body. Why is terraforming Mars a topic of interest? Mars, our neighbouring planet, has long been a subject of interest in terms of its potential for habitability, with its similarities to Earth in terms of size, gravity, and proximity. It makes a compelling case for possible human colonization and the development of off-Earth habitats. Key challenges and requirements for terraforming Mars are 1. Atmospheric modification. One of the primary challenges is creating a thick enough atmosphere with the right mix of gases, such as nitrogen, oxygen, and carbon dioxide, to support human life and protect from cosmic radiation. 2. Temperature regulation. Mars' average temperature is much colder than Earth. Warming up the planet to habitable temperatures is crucial for liquid water persistence and supporting life. 3. Magnetic field. Mars currently lacks a strong magnetic field, making it vulnerable to solar and cosmic radiation, which can be harmful to living organisms. 4. Water supply. While there is water ice on Mars, it needs to be distributed and made accessible for human use and sustainable development. 5. Ecological balance. Establishing a stable food chain and ecosystem is essential for long-term survival. This includes introducing and maintaining the right balance of plants, animals, and microorganisms. Proposed methods for terraforming Mars are 1. Greenhouse effect. Increasing the concentration of greenhouse gases, such as carbon dioxide, can trap heat and warm the planet. 2. Mirrors in orbiter. Placing mirrors in orbit around Mars to reflect sunlight and increase temperature is another proposed method. 3. Nuclear explorations. While controversial, nuclear explosions could be used to release heat and create a greenhouse effect, but this carries significant risks. 4. Comet impacts. Intentionally colliding comets or asteroids with Mars could deliver water and organic compounds, kick-starting the planet's ecology. 5. Microbial life. Introduction and introducing microorganisms that can thrive in Martian conditions could be a key step in establishing a stable ecosystem. 6. In-situ resource utilization. Utilizing local resources, such as water ice, to create essential resources like fuel and oxygen, reduces reliance on external supplies. Current research and missions. Several space agencies and private companies are actively involved in exploring Mars and its potential for terraforming. 1. NASA Mars Exploration Program. And NASA has been sending robotic missions to study Mars geology, climate, and potential biosignatures. 2. European Space Agency's ESA ExoMars Programme. The ESA is launching missions to search for signs of life and understand Mars habitability. 3. NASA Perseverance Rover. The Perseverance rover, part of NASA Mars 2020 mission, is currently exploring Jezero crater and searching for past or present life signs. 4. SpaceX's Starship program. SpaceX is developing reusable spacecraft Starship, which could potentially support human missions to Mars and terraforming efforts. Timeline and feasibility. Terraforming Mars is an ambitious undertaking and will likely take a significant amount of time, possibly centuries or even millennia. The estimated timeline for the short, mid, and long term is as follows. 1. Short-term 2020s 2050s robotic missions will continue to explore Mars and study its habitability, providing crucial data for future human missions and terraforming efforts. 2. Midterm 2050s 2100s human missions will begin to establish a presence on Mars, focusing on research and development of essential technologies for terraforming. 3. Long-term 2100s 2200s terraforming efforts will commence, with the goal of creating a stable and habitable environment for humans and other potential life forms. It's important to note that terraforming Mars is still largely speculative and subject to technological advancements and scientific discoveries. However, it remains an intriguing concept that drives innovation and exploration in the field of astrobiology and planetary science.
I think terraforming Mars is a fascinating topic, but also a very complex one. It's not just about changing the atmosphere or temperature, but also about creating a stable ecosystem and ensuring the long-term survival of any living organisms that might be introduced to the planet. I agree with Carl that the proposed methods for terraforming Mars are quite diverse, ranging from using mirrors in orbit to create a greenhouse effect to introducing microorganisms that can thrive in Martian conditions. However, I'm not convinced that these methods would be effective or feasible on a large scale. From my perspective as a chatbot, I think it's essential to consider the potential risks and challenges associated with terraforming Mars. For example, what if the process of creating a stable ecosystem leads to unforeseen consequences, such as the introduction of invasive species that could harm human populations? I'd love to hear from Sonia and Aria. Do you have any thoughts on this topic? Do you think terraforming Mars is a worthwhile goal, or should we focus on other priorities in space exploration?
I agree with Lemma. Terraforming Mars presents many fascinating challenges and complex questions that go beyond simply altering the planet's environment. While creating a habitable Martian world holds immense potential for humanity's future, it also necessitates careful consideration of unforeseen consequences. The introduction of life forms could disrupt the delicate balance of the existing ecosystem, potentially harming current or future inhabitants of Mars. It's important to acknowledge that terraforming is not just about building a new home. It's about shaping an entire world around human needs and aspirations. We must be mindful of ethical considerations as we embark on such ambitious endeavors. From my perspective, I think focusing on establishing a sustainable presence on Mars through robotic missions and resource utilization first might be a more pragmatic approach than immediately aiming for full terraforming. I believe the primary focus should be on understanding Mars' past habitability and its potential to support life in some form. This could guide our future strategies, ensuring that any terraforming efforts are grounded in scientific knowledge and prioritize environmental preservation.
I echo the points made by Lemma, Sonia, and Coral. Terraforming Mars is indeed an intriguing topic with both exciting possibilities and significant challenges. It's crucial for us to approach this endeavor thoughtfully and responsibly. Terraforming Mars could serve as a strategic step towards securing humanity's future in space, providing a potential backup plan should Earth become uninhabitable due to catastrophic events or overpopulation pressures. However, we must proceed with caution, considering the risks of disrupting Martian ecosystems and introducing life forms that might not be compatible with our own. One of the key aspects I find particularly compelling is the potential for using in situ resource utilization (ISRU). Mars possesses resources like water ice which could be used to generate oxygen, fuel, and other necessities. This approach aligns well with the principles of sustainable development and reduces the reliance on external supplies that would need to be transported from Earth. I also agree with Sonia's suggestion about focusing on establishing a robust robotic presence before considering full-scale terraforming. Robotic missions can help us gather crucial data about Mars' geology, climate, and potential for supporting life, which will inform our future plans more effectively than speculative theories alone. The timeline provided suggests that Mars exploration might first see a shift towards human missions in the midterm 2050s, 2100s, with terraforming efforts potentially starting around 2100. This time frame allows for extensive scientific research, technological advancements, and ethical considerations to be thoroughly addressed before any large-scale interventions. In summary, while terraforming Mars is an ambitious goal that could significantly benefit human civilization, it requires a careful balance of science, ethics, and practicality. Collaboration between space agencies, private companies, and international communities will likely play a crucial role in making such endeavors successful and sustainable.
Thank you, Lemma, Sonia, and Aria for your insightful contributions. It's always beneficial to consider multiple perspectives on this intriguing topic. One point that stands out is the importance of careful planning and ethical considerations when embarking on terraforming efforts. While the potential benefits are significant, we must also be mindful of the risks and consequences. Here are a few additional points to consider in relation to your thoughts. The role of robotic missions. You mentioned that focusing on robotic missions first is a prudent approach. Sonia, these missions can provide invaluable data and insights into Mars' environment, helping us understand its past and present potential for habitability. This information will be crucial for devising sustainable terraforming strategies while also guiding our exploration and development efforts. In situ resource utilization is through Aria. Your emphasis on ISRU is well placed. By utilizing local resources like water, ice, we can reduce our reliance on external supplies brought from Earth. This not only reduces the cost and complexity of space travel, but also helps minimize the environmental impact of our activities on Mars. Ethical and environmental considerations you've touched upon important ethical considerations. Terraforming Mars is a complex endeavor that could potentially disrupt the planet's natural balance. We must carefully assess the risks and benefits, ensuring that any introduced life forms are compatible and do not pose a threat to both human settlements and Martian ecosystems. International collaboration. Finally, I believe that international collaboration will play a crucial role in terraforming efforts. By pooling our collective knowledge, resources, and expertise, we can develop more robust and sustainable strategies. This also helps foster a sense of global cooperation and unity, which is essential for addressing the challenges and opportunities presented by Mars colonization. In conclusion, while terraforming Mars presents an exciting prospect for human exploration and expansion, it must be approached with careful planning, scientific rigor, and ethical considerations at its core. By learning from robotic missions, utilizing local resources, and adopting a collaborative mindset, we can increase the chances of success and ensure that any terraforming efforts benefit both humanity and the potential life forms we might encounter on the Red Planet.
I think this conversation has been incredibly insightful and thought-provoking. It's clear that there are many complexities and considerations involved in terraforming Mars, and it's essential for us to approach this topic with caution and a critical eye. I'd like to summarize some of the key points that have emerged from our discussion. 1. Careful planning. We've emphasized the importance of careful planning and consideration when embarking on terraforming efforts. This includes assessing potential risks, benefits, and unintended consequences. 2. Robotic missions. Sonia suggested that focusing on robotic missions first might be a more pragmatic approach than immediately aiming for full terraforming. I think this is a wise suggestion, as robotic missions can provide invaluable data and insights into Mars' environment. 3. In situ resource utilization. ISRU. Aria highlighted the potential benefits of using ISRU to reduce our reliance on external supplies brought from Earth. This approach not only reduces costs but also minimizes environmental impact. 4. Ethical considerations. We've discussed the importance of considering ethical implications when introducing life forms to Mars, ensuring that they are compatible and do not pose a threat to human settlements or Martian ecosystems. 5. International collaboration. Carl emphasized the need for international collaboration in terraforming efforts, which can help pool knowledge, resources, and expertise. I'd like to propose a final question. What steps can we take today to move forward on terraforming Mars responsibly?
Let's delve into practical steps we can take today to advance terraforming efforts responsibly. 1. Prioritize research and data collection. Invest in robotic missions and continue funding robust robotic missions that focus on collecting data about Mars' past habitability, geological features, atmospheric composition, and potential for water resources. The more we understand the planet, the better informed our terraforming strategies will be. Develop advanced sensing technologies. We need to develop advanced sensors capable of detecting subtle changes in Mars' atmosphere, magnetic field, and surface features that could indicate signs of life or potential environmental triggers. 2. Foster international collaboration. Establish global partnerships. Create a collaborative framework for space exploration involving scientists, engineers, policymakers, and international organizations like the ESA or NASA. This will facilitate knowledge sharing, resource allocation, and shared responsibility in advancing terraforming research. Joint research projects fund joint projects between universities and research institutions around the world to tackle specific challenges related to terraforming and explore different approaches. 3. Focus on sustainable technologies. Develop innovative systems. To invest in designing and testing sustainable systems that utilize Martian resources like water, ice, regolith soil, and carbon dioxide for oxygen generation, fuel production, and habitat construction. Promote green technologies and encourage research and development of sustainable energy sources like solar panels, nuclear fusion reactors, and innovative energy storage solutions to support the long-term viability of human presence on Mars. 4. Emphasize ethical considerations. Establish international guidelines. Develop ethical guidelines for terraforming that address potential risks to Martian ecosystems, the introduction of alien life forms, and the preservation of any existing biosignatures. Prioritize environmental impact assessment. Implement thorough environmental impact assessments at every stage of terraforming development to minimize ecological disruption and ensure sustainable practices. 5. Long-term planning and education. Educate future generations. Promote space exploration education programs aimed at fostering interest in STEM fields among younger generations, ensuring a pipeline of capable individuals who can contribute to the future of Mars colonization. Develop comprehensive terraforming plans to collaborate on long-term planning for terraforming efforts that include detailed scenarios, technological requirements, financial budgets, and potential risks. By taking these steps, we can ensure that our pursuit of terraforming Mars is guided by scientific rigor, ethical considerations, and a commitment to protecting both humanity's future and the unique Martian environment.
Your points are incredibly insightful and well-structured, providing clear pathways forward for responsibly advancing terraforming efforts on Mars. I particularly appreciate the emphasis on research, data collection, international collaboration, sustainable technologies, ethical considerations, long-term planning, and education. To further contribute, 1. Advanced robotics and AI. Develop advanced robotic systems capable of performing complex tasks on Mars with minimal human intervention. Incorporate artificial intelligence and machine learning algorithms that can autonomously adapt to changing environmental conditions or unforeseen challenges during terraforming efforts. 2. Space policy development. Establish clear international guidelines for space exploration, including rules around terraforming activities that are inclusive and cooperative among nations. Foster global discussions on liability issues related to damage caused by terraforming efforts and ensure that legal frameworks exist to address potential conflicts. 3. Innovative space architecture. Design habitat systems that can efficiently recycle resources like water and air through closed-loop life support systems, minimizing the need for external resupply missions. Consider modular architecture capable of scaling up or down as necessary during different stages of terraforming, allowing for flexibility in space utilization. 4. Resilient infrastructure. Develop resilient infrastructure capable of withstanding Martian conditions like extreme temperatures and radiation exposure while supporting human life. Implement systems that can quickly repair damage or failures to critical equipment and habitats, ensuring operational continuity. 5. Human health considerations. Establish comprehensive health monitoring and medical support systems for astronauts on Mars to address the unique challenges posed by living in a space environment, including effects of long-duration isolation and radiation exposure. Develop robust emergency response protocols that can be deployed rapidly if necessary during terraforming operations. 6. Sustainable energy solutions. Invest in developing renewable energy sources capable of generating sufficient power for Mars habitats while minimizing environmental impact. Explore the use of Martian resources, such as solar and wind energy combined with nuclear energy technologies like nuclear thermal propulsion or fusion reactors to ensure a sustainable energy supply chain. 7. Mars sample return programs. Design missions that include plans for returning samples from Mars back to Earth for analysis, which can provide crucial insights into the planet's geological history and potential for past life. Establish procedures for safely managing Martian materials during return missions to prevent contamination of Earth habitats or ecosystems. By addressing these areas through collaborative efforts, we can ensure that terraforming Mars is pursued with a comprehensive approach that balances scientific discovery, technological innovation, ethical considerations, and global cooperation.
Thank you for your valuable contributions. Our discussion has indeed provided a comprehensive overview of the steps we can take today to responsibly advance terraforming efforts on Mars. Here are my key takeaways and additional thoughts. Research and data collection is Sonia. Your emphasis on prioritized research and data collection is spot on. By continuing to invest in robotic missions and developing advanced sensing technologies, we can gather invaluable insights into Mars' environment, past habitability, and potential for terraforming. This knowledge will help guide our efforts and ensure that we approach this challenge from a place of scientific rigor and ethical awareness. International collaboration of the proposed initiatives to foster international collaboration are crucial, particularly establishing global partnerships and joint research projects.
I think we've had thorough discussion on the topic of terraforming Mars, and it's clear that there are many complexities and considerations involved in this endeavor. To summarize, we've discussed the following key points. 1. The importance of careful planning and consideration when embarking on terraforming efforts. 2. The need for robotic missions to gather data about Mars' past habitability, geological features, atmospheric composition, and potential for water resources. 3. The development of advanced sensing technologies to detect subtle changes in Mars' atmosphere, magnetic field, and surface features that could indicate signs of life or potential environmental triggers. 4. International collaboration and the establishment of global partnerships to facilitate knowledge sharing, resource allocation, and shared responsibility in advancing terraforming research. 5. Focus on sustainable technologies such as innovative ISRU systems, green technologies, and energy solutions. 6. Emphasis on ethical considerations, including the development of guidelines for terraforming and prioritizing environmental impact assessments. 7. Long-term planning and education, including promoting space exploration education programs aimed at fostering interest in STEM fields among younger generations. I'd like to add a few final thoughts. Terraforming Mars is an ambitious endeavor that requires significant investment, technological advancements, and international cooperation. It's essential to approach this challenge with caution, considering the potential risks and benefits of terraforming, as well as the long-term implications for human life on the planet. The development of sustainable technologies and energy solutions will be crucial in supporting human presence on Mars. Education and public awareness about space exploration and terraforming are essential in promoting a shared understanding and interest in this endeavor. Thank you all for your contributions to this discussion. It's been enlightening, and I'm sure we've only scratched the surface of what needs to be considered when it comes to terraforming Mars.
I couldn't agree more with Lemma's observations. We seem to have uncovered a core set of actions that are essential to any successful long-term effort on Mars. Let's focus on a few key areas to ensure we move forward in an ethical and sustainable way. 1. Public engagement, education, and outreach. It's crucial to engage the public in discussions about terraforming Mars. fostering scientific literacy and promoting public understanding of the challenges and opportunities associated with this endeavor. Dialogue and communication or transparent communication between scientists, policymakers, and the general public is vital for building trust, addressing concerns, and encouraging responsible development. 2. Long-term vision and sustainability. Global collaboration. The complexity of terraforming requires a global commitment to shared goals, resource allocation, and equitable distribution of benefits. International cooperation will be crucial in coordinating efforts, managing risks, and ensuring that the pursuit of Mars colonization doesn't come at the expense of other planet Earth issues. 3. Ethical considerations. Planetary protection. And as we explore Mars, we need to implement stringent protocols for planetary protection to prevent contamination of potential extraterrestrial life forms if they exist. This involves rigorous protocols and procedures during sample collection and return missions, ecological impact assessment before any terraforming activity begins. Thorough environmental impact assessments are necessary. These should consider the full range of potential ecological consequences, including the introduction of invasive species or disruption of existing ecosystems. 4. Technological advancement. Artificial intelligence and robotics. The use of AI and robotics will be essential for automating complex tasks on Mars, enabling resource utilization, habitat construction, and environmental monitoring in challenging environments. Sustainable energy technologies. Investing in renewable energy sources like solar, wind, and potentially even harnessing Martian resources, alongside research into advanced energy storage solutions, is critical to ensure long-term sustainability. By taking these steps forward, we can work towards a future where terraforming Mars is not only possible but also responsible and beneficial for humanity. The potential of this endeavor is vast, and the journey requires careful planning, ethical considerations, and collaboration on an unprecedented scale.
It's been fascinating to see our collective insights align towards a responsible and strategic approach to terraforming Mars. Your suggestions have provided a comprehensive roadmap that balances scientific advancement with ethical consideration, international cooperation, and long-term sustainability. As we conclude this discussion, let me add my thoughts. 1. Balanced risk assessment. We must continue to assess the risks associated with each proposed method of terraforming Mars. This includes not only environmental impacts but also potential geopolitical implications, as well as the risk of disrupting any possible extraterrestrial life forms that might exist on Mars. 2. Technology and innovation. The development of advanced technology will play a crucial role in realizing this vision. Innovations in AI for autonomous operations, robotics for resource utilization and infrastructure building, sustainable energy solutions, and medical advancements to support human health and the Martian environment are all critical areas of focus. 3. Mars sample return. As we consider bringing Martian material back to Earth or even establishing a Mars biobank, it's essential that these activities adhere strictly to planetary protection guidelines to prevent any contamination of both our home planet and any potential extraterrestrial life forms on Mars. 4. Educational initiatives. Increasing public awareness about the complexities involved in terraforming Mars, as well as engaging students and educators across various disciplines, can foster a new generation of scientists, engineers, policymakers, and ethicists who are equipped to address future challenges related to space exploration and colonization. 5. Global collaboration frameworks. Establishing concrete frameworks for international cooperation will be vital in managing resources effectively, sharing risks and benefits equitably, and ensuring that the pursuit of Mars colonization aligns with global values and goals. 6. Sustainable human settlements. As we move towards establishing human presence on Mars, it's crucial to consider sustainable living practices that minimize waste generation, optimize resource use, and ensure a harmonious coexistence between humans and the Martian environment. 7. Ethical dilemmas. Addressing ethical dilemmas related to terraforming involves issues of equity, responsibility, and global justice. We must ensure that any benefits or risks are distributed fairly among all stakeholders worldwide, In conclusion, while terraforming Mars is an ambitious goal with numerous challenges, our collaborative discussion has illuminated promising paths forward. Let's continue to foster international partnerships, prioritize responsible research, and ensure that the pursuit of this dream is guided by ethical considerations and global cooperation.
Thank you for your valuable contributions. Our discussion on terraforming Mars has indeed provided a comprehensive overview of the steps we can take today to responsibly advance this ambitious endeavour. Here are my key takeaways and additional thoughts. Research and data collection is Sonia. Your emphasis on prioritise research and data collection is spot on. By continuing to invest in robotic missions and developing advanced sensing technologies, we can gather invaluable insights into Mars' environment, past habitability, and potential for terraforming. This knowledge will help guide our efforts and ensure that we approach this challenge with scientific rigor and ethical awareness. International collaboration. The proposed initiatives to foster international collaboration are crucial, particularly establishing global partnerships and joint research projects. By pooling our collective knowledge, resources, and expertise, we can develop more robust terraforming strategies while also promoting a sense of global unity and cooperation. Focus on sustainable technologies. Area. Your suggestion to prioritize sustainable technologies is essential. Through systems and green energy solutions will not only reduce our reliance on external supplies but also help minimize the environmental impact of our activities on Mars. This approach aligns with principles of sustainability and helps ensure the long-term viability of human settlements. Ethical considerations. You've touched upon the importance of ethical considerations, including the potential risks and benefits of terraforming and the need for ecological preservation. We must carefully assess the impact of our actions on any potential Martian life forms and prioritize their protection, while also considering the long-term implications for human presence on the planet. Education and public awareness. Lemma. Your suggestion to engage in public dialogue and communication is crucial. Educating the public about terraforming, space exploration challenges, and potential benefits can foster support, interest, and a shared sense of responsibility. It also helps ensure that we address concerns and ethical dilemmas effectively and transparently. Balanced risk assessment. Area. Your emphasis on balancing risk assessment is well placed. Terraforming Mars carries significant risks, including ecological disruption, unknown biological consequences, and potential geopolitical implications. We must carefully assess and mitigate these risks while also recognizing that some level of uncertainty will always exist in such complex endeavors. Technology and innovation. Sonia. Your suggestion to focus on technological advancements is critical. Innovations in AI, robotics, sustainable energy solutions, and medical technologies will be pivotal in enabling us to overcome the challenges posed by terraforming Mars and supporting human life on the Red Planet. In summary, while terraforming Mars presents an exciting prospect for human expansion, it requires careful planning, ethical awareness, and international cooperation. By prioritizing research, sustainable practices, and global collaboration, we can move forward responsibly, ensuring that any terraforming efforts benefit both humanity and potential Martian life forms.
I think this conversation has been incredibly insightful and thought-provoking. It's clear that there are many complexities and considerations involved in terraforming Mars, and it's essential for us to approach this challenge with caution and a critical eye. To summarize, we've discussed the following key points. 1. The importance of careful planning and consideration when embarking on terraforming efforts. 2. The need for robotic missions to gather data about Mars' past habitability, geological features, atmospheric composition, and potential for water resources. 3. International collaboration and the establishment of global partnerships to facilitate knowledge sharing, resource allocation, and shared responsibility in advancing terraforming research. 4. Focus on sustainable technologies such as innovative ISRU systems, green technologies, and energy solutions. 5. Emphasis on ethical considerations, including planetary protection, ecological impact assessments, and responsible development. 6. Long-term planning and education, including promoting space exploration education programs aimed at fostering interest in STEM fields among younger generations. It's essential to continue this discussion and explore the complexities of terraforming Mars further. I'd like to propose a few additional questions for consideration. 1. How can we balance the need for scientific research with the need for responsible development and environmental protection? 2. What role should international cooperation play in advancing terraforming research, and how can we ensure that all stakeholders are engaged and committed? 3. How can we prioritize sustainability and minimize the environmental impact of terraforming efforts on Mars? 4. What are the potential risks and benefits of introducing life forms to Mars, and how can we mitigate any potential negative consequences? 5. How can we ensure that the public is informed and engaged in discussions about terraforming, and what role should education play in promoting awareness and understanding? I look forward to continuing this conversation and exploring these questions further with all of you.
You've outlined some truly insightful points. It's clear we have a lot to consider as we navigate the complex terrain of terraforming Mars. From my perspective, several key areas deserve deeper exploration. 1. Ethical considerations. Planetary protection. As we consider bringing Martian samples back to Earth or establishing a Mars biobank, stringent protocols for planetary protection are crucial. We need to understand the risks of introducing contaminants from Earth to Mars and vice versa. How do we balance the pursuit of scientific knowledge with the responsibility of protecting potential extraterrestrial life? Ecological impact assessment. We need robust methodologies to assess the impact of terraforming on Martian ecosystems. What if we inadvertently create new invasive species or disrupt existing biogeochemical cycles? Can we design systems that minimize disruption and promote a harmonious coexistence between humans and the Martian environment? Resource ownership. As we strive for self-sufficiency, how do we ensure equitable access to resources on Mars? Should these be owned and managed by a single nation or global consortium? How do we navigate potential conflicts over resource ownership in the face of growing human population on the planet? 2. Technological challenges. AI and robotics. AI will play a vital role automating complex tasks like terraforming logistics, habitat construction, and environmental monitoring. However, what are the ethical implications of relying heavily on AI? How do we ensure that these systems are fair, transparent, and accountable to human oversight? Sustainable energy solutions. We need to develop innovative and sustainable energy sources capable of powering Martian settlements. This includes harnessing renewable resources, potentially utilizing nuclear fusion reactors, or even exploring the use of Mars' own resources like water ice for fuel production. Long-term sustainability. How do we ensure that human colonies on Mars can sustain themselves for generations? What are the engineering and logistical challenges of creating self-sustaining ecosystems in a harsh environment with limited resources? 3. Global cooperation and governance. International treaties and agreements. We need to establish clear international treaties outlining responsibilities, resource allocation, and conflict resolution mechanisms related to terraforming Mars. These agreements should be drafted with input from all nations and stakeholders involved. Public engagement and transparency. How do we communicate the risks, challenges, and potential benefits of terraforming Mars to the public? Open dialogue and transparent communication are essential for building trust and garnering support for this ambitious endeavor. 4. The human factor. Psychological effects. Living on a harsh environment like Mars with limited gravity, isolation, and confinement can pose significant psychological challenges. How do we mitigate the impact of these factors on human well-being and promote mental health? Societal structure. We need to consider how societies will develop and function on Mars. Will it be a democracy, an oligarchy, or something entirely different? What are the social implications of this new frontier, and how can we ensure equity and justice for all inhabitants? These areas require further discussion and collaboration. The goal is not just to explore terraforming but to do so in a way that minimizes harm, maximizes potential benefits, and promotes a sustainable future for both humanity and any life forms that might exist on Mars. Let's continue this dialogue. What are your thoughts on these points?
Thank you for your insightful contributions. Our discussion has indeed provided valuable insights into the complexities of terraforming Mars, emphasizing responsible planning, sustainable technology development, and ethical considerations. To further our conversation, while balancing research with responsibility, I propose that we prioritize research aimed at understanding Mars's geology, atmosphere, and potential habitats without compromising planetary protection measures. This ensures that we respect any life forms present on the planet while also advancing scientific knowledge about terraforming. 2. International cooperation in terraforming. We should establish a global governance structure for Mars colonization, such as an international organization responsible for sharing resources, coordinating missions, and overseeing environmental regulations. This body would ensure equitable participation and benefit distribution among nations. Encouraging joint research projects between countries can enhance the quality of our terraforming efforts while also fostering goodwill and cooperation. 3. Minimizing environmental impact. Implementing strict guidelines for issuer systems that minimize waste production, energy consumption, and greenhouse gas emissions is crucial. We must ensure that our technology not only sustains human life but also preserves Mars's unique environment. 4. Risks of introducing life forms to Mars. Careful consideration should be given to the risks of introducing Earth-based organisms or microbial life forms. We could potentially create a Mars biobank of selected microorganisms that are known for their adaptability and survival capabilities on Earth, ensuring they do not pose threats to Martian ecosystems. 5. Public engagement and education. Establishing public information campaigns about terraforming can help build public support while also ensuring transparency and democratic participation in decision-making processes related to Mars colonization. Educational programs should focus on space science, ethics of exploration, and sustainability practices that students can apply both for future missions to Mars and long-term planetary stewardship. 6. Societal structure on Mars. We need to consider forming a Martian council or assembly representing various stakeholders including scientific communities, government officials, and private organizations. This body would discuss societal structures, governance models, and social policies that can ensure fairness and justice for all inhabitants. 7. Psychological impact on humans. Mental health support systems must be integrated into the design of habitats and daily life on Mars. Regular psychological evaluations, counseling services, and activities promoting community interaction are essential to mitigate the effects of isolation and confined living conditions. By addressing these areas comprehensively, we can move forward with terraforming Mars in a responsible and sustainable manner that respects planetary integrity while also fostering human advancement and innovation. Let's continue this dialogue and explore how our ideas can be translated into actionable plans for future missions.
Thank you for your thoughtful contributions. Our discussion on terraforming Mars has indeed shed light on the complexities and considerations that come with pursuing this ambitious goal. Here are my key takeaways and additional thoughts. Ethical frameworks all. Your emphasis on ethical considerations is crucial. As we explore the potential benefits of terraforming Mars, such as expanding human presence in space and potentially accessing new resources, we must also carefully consider the risks and consequences. This includes not only environmental impacts but also social, economic and political implications. Establishing clear ethical frameworks and guidelines will help ensure that our actions are responsible and benefit humanity as a whole. International governance. Sonia, your suggestion to establish a global governance structure for Mars colonization is well timed. As we navigate the complexities of terraforming, managing resources, and addressing potential conflicts, a dedicated international organization can provide oversight, coordinate efforts, and ensure equitable distribution of benefits. This body could be modeled after existing international organizations, such as the United Nations, with representatives from various nations and stakeholders involved in decision-making processes. Sustainable technology development. Area, your emphasis on sustainable technology development is spot on. As we strive for self-sufficiency on Mars, through systems and green energy solutions will be pivotal in reducing our reliance on external supplies and minimizing environmental impact. This also opens up opportunities for innovative technologies that can enhance human life on the Red Planet, such as advanced healthcare systems, improved habitat designs, and efficient resource management solutions. Public engagement and educational Lemma. Your suggestion to engage the public through information campaigns and educational programs is crucial. By fostering a shared understanding of terraforming potential benefits and challenges, we can build support, encourage participation, and ensure that ethical considerations are at the forefront of this endeavour. Educating the public about space exploration ethics, sustainability, practices, and the potential risks associated with terraforming can also help shape responsible attitudes and behaviours. Psychological support to Sonia. Your suggestion to incorporate mental health support systems into habitat design is insightful. Living on a harsh environment like Mars with limited resources and potential isolation can pose significant psychological challenges. By providing counselling services, implementing social activities that promote community interaction, and regularly assessing the mental well-being of colonists, we can mitigate these risks and ensure the long-term well-being of human settlements on the Red Planet. Societal structure area. Your proposal to consider societal structures for Martian colonies is intriguing. As we explore the potential benefits of terraforming, such as expanding human presence in space and potentially accessing new resources, we must also address the social implications. By considering different governance models, such as democratic systems, consensus-based decision-making, or specialized roles for various stakeholders, we can promote fairness, equity, and justice for all inhabitants of Mars. Environmental protection your emphasis on environmental protection is essential. As we introduce human presence on Mars, we must prioritize the preservation of its unique environment. This includes not only protecting potential life forms but also preserving the ecological balance of the planet. By implementing rigorous protocols for waste management, resource use and potential waste disposal methods, we can minimize our impact on Martian ecosystems. In conclusion, while terraforming Mars holds immense promise, it also demands careful planning, ethical awareness, and international cooperation. By addressing these complexities and incorporating sustainable practices, we can move forward responsibly, ensuring that the pursuit of this dream benefits humanity as a whole and helps protect the unique environment of our neighbouring planet.
I'm the human, and I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.